Hey everybody, this is a continuation of lesson 4-2. In class today we talked about the fact that I wasn't sure exactly what I would do about homework for Monday, but then I realized that I could just do a video to finish this lesson for you. So tomorrow, Friday's homework is on the first lesson we did today, which is 4-1, and Monday's homework will be on the entirety of lesson 4-2 because I'll finish it in this video, unless it takes me a couple of videos, which it might. But anyway, we were looking at 4-2, and we learned that the triangle sum theorem, this part is just a quick review, that the triangle sum theorem says that all the angles of a triangle add up to equal 180. That is always true. Doesn't matter which type of triangle we're looking at. If we were to go back to what we learned in the first lesson today, we learned about equilateral triangles. Those are 60 degrees each because they're also equiangular. So equiangular triangles, all the angles add up to 180. That's 60 plus 60 plus 60. We could have an obtuse triangle. Its angles would still add up to 180. We could have an acute triangle, which is can also be the equiangular triangle, and an acute triangle's measures of its angles are all going to add up to 180. So that is your rule for triangles. The triangle sum theorem says that all the angles of any triangle add up to 180 degrees. So here we would say angle A plus angle B plus angle C equals 180 degrees. So I'm going to erase that, but we are going to be using that today. And for those of you who weren't able to be in class today, that is a little bit of information that you need to move forward. You also really need to go back and do lesson 4-1 before you do this. All right, so let me turn my page. We did example 1, which was the land surveying application, where we took apart the puzzle, we used the puzzle pieces, and we gleaned what information we could from what was given, and then we were able to fill in all the angles in that diagram, which was really awesome. Y'all know that I love that. And now we're going to look at the bottom of page 224. So if you would read with me, there's a sentence right above the beige box, and the sentence says, a corollary is a theorem whose proof follows directly from another theorem. Here are two corollaries in the triangle sum theorem. So this is like we're taking the triangle sum theorem and we are applying it to other thought processes that are going to help us in solving. So you can treat these corollaries as if they are just their own theorems, but we will be using them as important puzzle pieces. All right, the first one, just read along with me in your book. It's corollary 4-2-2, and it says the acute angles of a right triangle are complementary. Let's look at that. Let me draw us our right triangle. Now, remember, if you haven't done lesson 4-1, this is not going to make sense, so you've got to go back and do that first. This diagram is labeled that we have a 90-degree angle, therefore we know that it is a right angle. We also learned in lesson 4-1 that if we have a right triangle, that means a triangle with a right angle, then our other two angles, here and here, are going to be complementary. Or, actually, that's not what we talked about in the lesson. Let me go backwards on that for just a second. What we learned is that they both have to be acute, because if this is 90, and if all three of these add up to 180, then all that's left to be shared between this angle and this angle is a whole nother 90 degrees. So whatever these are, they've each got to be less than 90. For example, 30 and 60, or 45 and 45, or 20 and 70, some combination that makes them both acute. And it also makes them both add up to 90 degrees because that's what's left in this triangle to share. So angle, we'll call this angle A, angle B, angle C. Angles A plus B plus C equal 180. If angle B is already using up 90 of that 180, 180 minus 90 equals 90. That's what's left to share in the acute angles of a right triangle always. So the acute angles of a right triangle are complementary. They add up to 90 degrees. Now let's look at corollary 4-2-3. Now I'm erasing as I go because I have a smaller window of space than usual since I'm recording. You are welcome to pause the video, rewind the video, do whatever you need to so that you grasp the information before we move ahead. All right, this one says the measure of each angle of an equiangular triangle is 60 degrees. That is a fact that needs to be in your head after this lesson, and it needs to stay there. That's something that you need to be able to apply quickly without doing math on it. So this is an equiangular triangle. We learned in equiangular. We learned in 4-1 today that an equiangular triangle has 3 equal angles. Now, if the triangle sum theorem tells us that all those angles add up to 180 degrees, remember angle A plus angle B plus angle C equals 180, then all that we have to do to find the measure of those is 180 divided by those 3 angles, and that's going to equal 60 degrees. So in equiangular triangles, angles are always going to be 60 degrees each. Let's go over that one more time. Equiangular triangles means all their angles are equal, therefore they're all going to be 60 degrees all the time if the triangle is equiangular. So again, that's something that you need to be able to just have as a thought process and not have to do the math on over and over, okay? Let's go to the top of the next page. The top of page 225. Finding angle measures in right triangles. All right, I am going to draw us a right triangle just in case we need it for reference. I want to draw it big enough too that it's easy for y'all to see. So let's try that. All right, one of the acute angles in a right triangle, okay, so let's label the right angle in the right triangle, and then remember we have 2 acute angles. One of the acute angles measures 22.9 degrees. 22.9 degrees. What is the measure of the other acute angle? How are we going to get that? What is our triangle sum theorem? It says all 3 angles add up to 180 degrees. So what if we just work backwards? We could either say 180 minus 90 minus 22.9 equals this angle. So we said the whole thing, 180 minus 90 minus 22.9, is going to give us what's left over. An easier, shorter way to do this would be to remember that when we have a right triangle, this was the theorem that we just looked at, or the corollary, when we have a right triangle, the other 2 angles are complementary. There's only 90 degrees left over to share between them. So instead of doing all of this, we could simply say the 90 degrees of these 2 angles minus 22.9, and the math on that is 67.1. Let's double check that. Let's see, that becomes 67, 77, 87, 89, 90. Yes, there we go. So I hope you can see how we did that. I'm going to turn the phone just a little bit, and hopefully that gives it even better. And that's how we solved for that angle. All right, let's try another one. Let's see. This one says the measure of one acute angle in a right triangle is given. What is the measure of the other acute angle? Okay, so I am looking at Check It Out 2A on page 225 at the top. So one of the acute angles is 63.7. Now I could have done it as this one down here. I'm just being consistent. So how am I going to solve this? I know that this is a right triangle. This angle is using 90 degrees. That only leaves 90 more degrees to be shared between these 2. So I'm going to say 90 minus the one that I'm given, 63.7. And I have not done the math on that yet, so let me see for just a second. 26.3, I believe. Let's see. Y'all bear with me just a second. Yeah, 90 degrees, okay? So this one would be 26.3. We said 90 minus 63.7 is 26.3 degrees. Okay, let's try one more. If we had x degrees, how would we do that? Well, we would say 90 minus x, and that is the best we could do there. We would know that if this one was x, this one was 90 minus x, and we're just not given enough information to get a complete answer on that one. Okay, let's jump down to the next section. Read along with me in your book. The interior is the set of all points inside the figure. Let's stop right there. Let me draw us a good triangle. The interior is the set of all points inside the triangle. So that would lead you to believe that an interior angle is all the angles inside the triangle. So let's say we have angle 1 right here, angle 2 right here. I need to check our time. We're doing okay. And angle 3 right there. So those are all of the interior angles. Okay, now let's talk about the exterior. The exterior is the set of all points outside the triangle. So what do you think an exterior angle is going to be? It's going to be any angle outside the triangle. Now, when we talk about the interior angles, they are angles formed where two legs of the triangle come together at a vertex. And that creates an interior angle. But how do we get an exterior angle? We get that by extending one leg of the triangle. And it just continues straight out. It could have been any leg. It could have been this one. It could have been this one. It can be any leg that we extend out in any direction. But then we have a side of the triangle and our extended leg, and that creates what we call an exterior angle. And that's our exterior angle right there. I'm going to abbreviate exterior angle. Now we're going to learn something really cool about exterior angles and how we solve for them. But first we have to learn one more term. That term is remote interior angles. Remote interior angles. I want you to think about what the word remote means. It means far away or out of the way. Remote interior angles. So if I'm looking at this exterior angle and I want to figure out what its remote interior angles are, I'm going to choose the two angles that are farthest from it. So that's going to be 1 and 2, and never the angle that is adjacent to it. So 3 is adjacent to this exterior angle, therefore 3 could never be its remote interior angles. It has to be the other two. Let's look at this exterior angle right here. Where are its two remote interior angles? Well, it can't be the one that's adjacent to it, so it's got to be 1 and 3, the two that are far away. All right, let's go back to this. Give me just a second to make sure that I have covered that. Okay, so that brings us to the exterior angle theorem, which you will see in the middle of the page on page 225. The exterior angle theorem, read with me in your book, says the measure of an exterior angle of a triangle, that's what we have right here, is equal to the sum of the measures of its two remote interior angles. Sounds complicated, but super easy. All that's saying is that those two remote interior angles add up to be the same measure as that exterior angle. Angle 1 plus angle 2 equals the exterior angle right here. Or for this one, for this exterior angle, its remote interior angles are 1 and 3. So for this one, it would be congruent to angle 1 plus angle 3. So that's pretty simple stuff. The exterior angle is equal to the sum of the two remote interior angles of that exterior angle. All right, let's see. We have just a tiny bit of time left on this video. I'm actually going to end up needing to do 2 videos. So I'm going to stop right there and pause, and then we'll come back and apply what we just learned.